Hello viewers, you may recall the transmission model, the communication model that you have discussed in the last class. There we have seen you require a medium which provides the physical path between the transmitter and receiver. So through this medium, the digital data or analog data, whatever it may be, in the form of signal is transmitted through the medium from source to destination. The transmission media can be broadly divided into two types: guided and unguided. In both the cases, electromagnetic wave is used for transmission from source to destination. But in case of guided media, the signal is guided through some solid medium. The solid medium can be a twisted pair of wire, or it can be an coaxial cable, or an optical fiber. And in case of guided media, the media plays an important role in the transmission quality of the signals. That means the quality of the signal that you receive at the other end, in the receiving end, depends primarily on the characteristics of the media and of course the signal that you are sending. On the other hand, in guided media like air, or it can be free space, or even it can be seawater, the electromagnetic wave is not guided by any medium, but in this case the antenna which is used to inject the signal into the transmitted media, the transmission media plays an important role. So we shall consider these transmission media one after the other. Let us first consider the twisted pair of wire. In case of twisted pair, let us first of all look at the physical characteristics. In this case, you have is and wire. There are two wires which are insulated. Then they are twisted together in a spiral form like this. You may be wondering why this twisting, why it is necessary to twist a pair of wire in this manner. The reason for this is when a pair of wire is used, the electromagnetic wave or the electrical signal passes in one direction in one of the wires, and the return path of the signal is through another wire. So the direction of the signal is in the reverse way, in the other direction. So the electromagnetic radiation that takes place because of the flow of current through the wire is in one direction for this wire, and it is in another direction through the other wire. And as a consequence, since they are kept at very close proximity, they cancel each other. In other words, when this twisted pair of wire are bunched together, then the electromagnetic radiation will not affect other wires which are placed very close, or rather it will affect very in a small way if they are close together. Usually this kind of pairs of wires are bunched together, maybe tens or hundreds of such wires are cabled together, then they are put inside a tough sheath of plastic and then sent over a long distance. So to reduce this effect of this mutual interference or crosstalk, whatever we call it, it should be minimized. So twisting of wire is done for that reason. Now, what is the diameter of these wires? You are using two wires. The diameter varies from 0.16 inch to 0.05 inch. And usually these are stated as say 26 gauge or this is 16 gauge GAUG. So the wire diameter is specified in terms of wire gauges. Usually the range is 0.016 inch to 0.05 inch. Now they are available in two varieties. One is known as UTP and another is known as STP. In this case, we have seen that this type of pairs of wires are bunched together, a large number of them, and sent over a long distance. And if there is no shielding done, then it is called unshielded twisted pair. But if you want to reduce the interference, external interference or crosstalk, what can be done? This can be covered by a cylindrical braided shield or a conductor which can be grounded. Then it is called shielded twisted pair. We shall see that the transmission characteristics of the shielded twisted pair is superior to unshielded twisted pair. Now, again, there are two categories. One category is called category 3, another is category 4, cat 3, cat 4 or cat 5 as usually we call them. This category is usually dependent on what is the number of twists per unit length. More the number of twists, the characteristics is better. So in case of cat 5, the number of twists per say inch will be more than for cat 3. Of these three types, cat 3 and cat 5 are quite popular. Voice grade category 3 cable is widely used in various applications, as we shall see, and with this you can go up to 16 megahertz. Data transmission rate can be 16 megahertz. And using cat 5, which is called data grade, you can go up to even 100 megahertz. So you see that depending on which category of where you are using, the transmission characteristics is also dependent. Now let us see other characteristics. One of the most important characteristics is the attenuation. The attenuation takes place as the signal traverses distance. So attenuation is expressed as decibel per kilometer. What is decibel? Decibel is a unit which is expressed as 10 log P1 P2 by P1. That means the P2 is the received power, P1 is the transmitted power, then 10 log P2 by P1 is the loss expressed in dB, decibel. And usually in case of guided media, this varies in logarithmic manner, logarithmic scale. That means if you plot in this way, say 10, 100, 1000 and so on in the x direction, and in the y direction if you plot the attenuation, it will be linear. It also varies with frequency. That means the attenuation of the electromagnetic wave that is sent through the transmission media varies with frequency. Let's see the characteristic curve for this. In case of uh, in this scale, say 1 kilohertz, that is the frequency, 1 megahertz, and say this is 10 megahertz. And here the attenuation is say 1, 10 and 100. So attenuation varies in this manner. As we see, the attenuation sharply increases with the frequency. That means the frequency characteristics of the twisted pair of wire is not very good. The attenuation sharply increases as the frequency increases. And that's why we shall see that the characteristics is, I mean, the signal is the data rate has to be restricted over a limited range. Now, if we plot the frequency and say this is cat 3, cat 5, and say this is for UTP, and this is say cat 5 STP. Then, or it is usually called 150 ohm. That means it is balanced, terminated by 150 ohm resistances. Frequency say 1, 4, 16, 25, 100 kilohertz, 300. Then for cat 3, the loss is 2.6, 5.6, 13.1, that is dB per kilometer. So as the frequency is increasing, as you can see, the attenuation is increasing. Similarly for here 2.0, 4.1, 8.2, 10.4 and 22 or 100 kilohertz. For STP, shielded twisted pair of wire, it is 1.1 dB, 2.2, 4.4, 6.2, 12.3 and 21.4. As I told, the transmission characteristics of shielded twisted pair is much better compared to unshielded twisted pair. So we can conclude that for UTP or STP or for twisted pair of wire, it has to be limited over distance, bandwidth, and data rate. Usually, distance that can be covered without putting a repeater varies from, I mean, it is few kilometer. Bandwidth, as we have seen, it can be up to 100 megahertz. Sorry, I think here it has to be megahertz. So, unshielded twisted pair can go up to 100 megahertz. Then data rate can be, say, 100 megabits per second. Now, what are the applications? Of this twisted pair of wire? Twisted pair of wire is possibly most cheap, most low cost, that means cheapest, and most widely used, particularly in telephony. For connecting wires from exchange to the house, twisted pair is commonly used. It is also used in telephony for other purposes, for signaling. Twisted pair is also used for local area network. Within a building. And particularly with the widespread use of structured cabling, which we shall discuss later, this twisted pair of wire is widely used. Let us now consider the second guided media, that is coaxial cable. In case of coaxial cable, the physical characteristics is like this. Physical characteristic, it has got a solid cylindrical conductor in the form of wire. The diameter varies from 0.4 inch to 1 inch. This solid cylindrical wire is covered by an insulator. There is an insulator, and this insulator, on top of this insulator there is another conductor that is in the form of a hollow cylinder. That means there is a inner conductor which is solid. It has got insulator. Then there is an outer conductor which is usually in the braided form like this, mesh of wire. And then this is covered by a plastic sheath. So on top of this you have got a plastic sheath. So this is the physical characteristics of the coaxial cable. Now let us look at the transmission characteristics. So far as the attenuation over distance is concerned, it is same as the twisted pair of wire. Usually it varies in logarithmic scale, but the frequency characteristics is little bit better, say 1 megahertz, 10 megahertz, 0.1, 1, 10, say this is 30, and it is like this. As you can see, the frequency characteristics does not change as sharply as it takes place in case of twisted pair of wire. Here it is more or less linear. On the other hand, as you have seen in case of twisted pair, it sharply increases, which is not true in case of coaxial cable. So it has got superior characteristics. Another important property is it is because of this shielded nature. You see, this outer conductor is shielding the inner conductor. As a consequence, it is less susceptible to EMI, electromagnetic interference, and crosstalk. And as a consequence, the bandwidth is higher than twisted pair of wire. It is about 400 megahertz. Repeater spacing can be few kilometers. Now let us see the applications. This coaxial cable is another media which is very popular apart from twisted pair. It is another which is commonly used, another medium which is commonly used in various applications. Most common one is for cable TV. In cable TV, 10 to 100 TV channel signals are sent from the community antenna to different users through a coaxial cable of, say, several tens of kilometers in a small town, in a village. So the cable is distributed from the community antenna. So CATV means community antenna TV, CATV. It is also used for long distance telephony. In long distance telephony, this can be used for sending signals over a distance of several tens of kilometers. But most popular use, as we shall see later, in case of local area network. In local area network, it is widely used in implementing popular standard LANs like Ethernet and also other types of LANs. Using coaxial cable some time back, a standard for metropolitan area network MAN has been developed, where coaxial cable is also used as the transmission media. Let us now focus our attention to the third media, that is the optical fiber. Let us first consider the physical characteristics. Here you have got the core, a core material made of plastic or glass. this core material is covered by another cylindrical material of different optical property. This is known as cladding, and this cladding is covered by a plastic sheath that is called jacket. So you can say have a cross-sectional view like this. Now let the inner diameter be d1 and outer diameter be d2. That means the diameter of the core is d1, diameter of the cladding is d2, and the optical property, that is the refractive index n1 is for core, n2 is for the cladding. Now this n1 and n2 satisfies an important relationship. n1 is made greater than n2. This is necessary so that whenever a light signal is injected, say suppose this is the this is the optical fiber cable. Now an electrical signal is injected here. Since n1 is greater than n2, from your knowledge of school level physics, you can tell that this light will suffer total internal reflection like this, and without much of signal loss, it will be transmitted to the other end of the cable. So the refractive index of the core material has to be more than the cladding material. Now what about the diameter? So this can be represented, the relationship can be represented by this, say this one and this one. So this corresponds to n2, this corresponds to n1, two different refractive indexes. So far as the diameter is concerned, d1 varies in the range from say 50 to 200 micrometer, that means 10 to the power minus 6 meter, and d2 varies from 125 to 400 meter. One popular type which is commonly used, where the d1 is 62.5 micron and d2 is 125 micron. This is one popular type. Here, as you can see, the refractive index of these two materials are distinct. So there is a step change in refractive indices when the signal goes from this core material to the cladding material. That's why it is called step index. There is another possibility. What can be done? The refractive index of the core material can vary slowly, and it can be highest as it approaches the core. So it is like this. That means it is maximum at the center. Say this is the core material. The refractive index is the highest at the center, and then it is lesser as you go to the outer edge of the core material. Then of course you have got the cladding of different refractive index. What will happen to the optical signal or the light when it is injected here? Here the signal will pass in this manner, transmitted in this manner. Instead of sharp reflections, Here it will bend slowly and go from one end to the other in this way. So the characteristics of the optical signal is quite linear. So this is called step index. Now let us look at another property of optical fiber. Here we have seen because of this diameter of 50 to 200 micron, a large number of optical signal or rays, you can say, uh, is getting reflected and going to the other end. Since different ray will have different length because of the distance traversed inside the core will be different, after some distance the quality of the signal will deteriorate. So that means it will not be good. How it can be improved? This can be improved by using a very small core diameter. This diameter has to be of the order of the wavelength of the optical signal, and it is of the order of 8 to 10 micron, and the outer core diameter of course is fixed, it is about 125 micron. Here it is step index, but it is very small in diameter, and in this particular case we can visualize it in this way, as if a single ray is getting transmitted from one end to the other end instead of multiple rays, and that's why it is called single mode fiber. So SMF. On the other hand, the other two is called multi-mode fiber, because multiple signals are passing, getting transmitted, for multi-mode fiber, MMF. Now, what kind of light source is used? In case of multi-mode fiber, light source is usually LED, light emitting diode. So light emitting diode is used in case of multi-mode fiber, and you can, so this is the source of light, and as detector you can use photodiode to convert the optical signal to electrical signal. For single mode fiber, the light source is laser, and you can use some diode, photodiode, same thing as the detector of the light. Now let us consider the characteristics of this optical fiber cable. The optical fiber cable gives you bandwidth, that means the signal goes from 10 to the power 4 to 10 to the power 5 megahertz. This is the range of the signal that can pass through the optical fiber, and the characteristics, attenuation characteristics is like this. So this is 1 terahertz and this is a 10 terahertz. This is 0.1 and this is 1 dB per kilometer. on this side. On this side it is 1 terahertz, 10 terahertz, and it has been found that characteristics is like this. So over a narrow band, signal can pass without attenuation through the optical fiber, and this narrow band is 10 to the power 14 to 10 to the power 15 of megahertz. Usually 3 band of frequencies are used. These 3 band of frequencies are 850 nanometer, 1300 nanometer, 1550 nanometer. That is the wavelength of the signal that is commonly used. So these 3 commonly used signal bands are used in case of optical fiber. Here the light source is LED. In other 2 cases it has to be laser. And using this 850 nanometer, you can go up to 100 megabits per second, and using 1300 nanometer and 1550 nanometer, you can go up to 1000 megabits per second. So we have seen that the optical fiber provides you higher bandwidth, lightweight, low attenuation, and since the signal is not electrical signal, the signal is optical in nature, it is immune to electromagnetic interference, EMI. So it is much less susceptible to, or not susceptible to external electromagnetic interference. It also provides greater repeater spacing. For multimode fiber, repeater spacing can be 2 kilometer. For single mode fiber, it can be 20 kilometer. Another important property is it provides you much higher security. In case of twisted pair of wire, or in case of coaxial cable, when the cable passes through outside the building, there is a possibility of tapping. But in case of optical fiber, there is no possibility of eavesdropping, that is called eavesdropping. It is not possible. And finally, the applications. So far as applications is concerned, optical fiber is used in case of telephony. Optical fiber cable can be laid over hundreds of kilometers, even under the sea, to link different countries. And second most important application is in high speed LAN, as we shall discuss later. So friend, let me conclude our lecture by telling that in this particular lecture we have considered 3 important guided transmission media: twisted pair of wire, coaxial cable, and optical fiber. In my next lecture, we shall consider the unguided transmission media and how unguided transmission media is used for communication as transmission media. Thank you.